Hello viewers, in today's class we are going to discuss one important problem from differentiation involving modulus function, right? So here we have a very important conceptual problem in which we are given a function f of x is equal to mod of x plus mod of cosine x, right? And we have to find the derivative of f of x at x is equal to pi by 2, right? So here the problem is to find out the derivative of this function, which is the sum of two mod functions, right? At this point x is equal to pi by 2, right? So for this what we will do, we'll try to find out the left hand derivative and the right hand derivative of this function f of x at x is equal to pi by 2, right? And we'll see whether the right hand derivative and the left hand derivative exist or not, or if they exist then they must be equal for the derivative to exist at x is equal to pi by 2, right? So let us start and let us first find out the left hand derivative, and then I will find out the right hand derivative. So now see here we are given this point x is equal to pi by 2, right? So here we have the sign convention, that is this is 0, this is pi by 2, this is pi, this is 3 pi by 2, and this is 2 pi, right? So in the first quadrant, that is when we go from 0 to pi by 2, right? So first we'll consider this interval, right? So it means we are in the first quadrant, and in the first quadrant we know that all the trigonometric functions are positive, so cos x is also positive, right? So when x lies between 0 and pi by 2, then mod of x is simply equal to positive x, because all the x are positive, and mod of cos x is positive cos x, right? So now f of x can be written as x plus cos of x, right? So we have redefined this function as f of x is equal to x plus cos x in the interval that is x belonging to 0 to pi by 2, right? Okay, so now we have this form of the function, right? So now what we will do, we'll define this function for x greater than pi by 2 and less than pi, right? So first we have defined this function in the first quadrant, and now we'll define this function in the second quadrant, right? Because when we define this function in the first quadrant, we'll make use of this function to get the left hand derivative of this function, right? And when we define this function in the second quadrant, that is x greater than pi by 2 and less than pi, right? So when x is greater than pi by 2 and less than pi, then mod of x is simply equal to positive x, because all the x are positive from pi by 2 to pi, right? And moreover we are measuring the angles in the anti-clockwise direction, right? Okay, and in the second quadrant we know that the cosine function is negative, right? So mod of cos x is negative in the second quadrant, right? So now we can write, or we can redefine this function f of x as positive x, because mod of x is plus x, and here we have negative of cos x, right? And where x belongs to pi by 2 to pi, right? So now we have the function f of x as x minus cos x when x goes from pi by 2 to pi, right? So now we can redefine, or we can rewrite this function as f of x is equal to x plus cos x when x belongs to 0 to pi by 2, right? And f of x is equal to x minus cos x when x belongs to pi by 2 to pi, right? And now we'll utilize this result for getting the left hand derivative, right? So the left hand derivative of this function may be denoted by f prime of x, and here we can put a negative sign, right? So f prime of x, that is the left hand derivative of this function at x is equal to pi by 2 is it can be obtained by differentiating x plus cos x with respect to x, right? So we have dy dx of x plus cos x. So this is 1 minus sin x, right? The derivative of x is 1 and the derivative of cos x is sin x, right? And similarly, the right hand derivative can be obtained by differentiating this result or this expression with respect to x, right? So the right hand derivative is f prime of x. Here we'll put a positive sign, and now we can write dy dx of x minus cos x. So this is the derivative of x is 1, and here the derivative of cosine x is negative sin x, so this becomes positive sin x, right? So now we are given the problem that we have to find the derivative of this function at x is equal to pi by 2, right? So when we take x is equal to pi by 2 here, then we'll get the left hand derivative as equal to 1 minus sine of pi by 2, right? So in this expression, we'll take x is equal to pi by 2, right? And sine pi by 2 is 1, so we have 1 minus 1, that is equal to 0, right? So the left hand derivative of this function at x is equal to pi by 2 is 0, right? And when we take x is equal to pi by 2 in this expression, then we'll get the right hand derivative at x is equal to pi by 2, and we have 1 plus sine pi by 2, right? So here we'll take pi by 2. So sine pi by 2 is 1, so we have 1 plus 1, that is 2, right? So the right hand derivative is equal to 2, right? So viewers, here we see that the derivative of this function at x is equal to pi by 2, it does not exist, right? Why? Because the left hand derivative is 0 and the right hand derivative is 2, and the left hand derivative is not equal to right hand derivative, right? Because we know that for the derivative to exist, the left hand derivative must be equal to right hand derivative at that particular point or the point of consideration, right? So here, although the left hand derivative is finite and it exists, the right hand derivative is also finite and it exists, but both the derivatives are not equal, right? So we can claim that the derivative of this function at x is equal to pi, it does not exist, right? It does not exist. So although in the problem we have written that find the derivative of this function at x is equal to pi by 2, so we'll proceed like this, and we arrive at the result that the left hand derivative and the right hand derivative are not equal. Hence the derivative of this function at x is equal to pi by 2, it does not exist, right? So this is how with the help of the concept of the definition of mod function and the sign convention of trigonometric functions, we can solve these type of problems.